Hi, I'm Dr. Pramod Shekharan Nair. Welcome you to my video on Apriori algorithm. Before I start with this algorithm, let me tell you, those who have not watched my previous video on association rule mining are requested to watch that video first before you watch this video for better understanding on association rule mining and reasons to have this algorithm. Apriori algorithm is an influential algorithm for frequent item set mining and association rule learning over relational databases. The a priori algorithm was proposed by Agarwal and Srikanth in 1994. This algorithm uses two steps, join and prune, to reduce the search space. Let us have go through on important terms of association rule mining before we start a priori algorithm to give you a base on how it starts with. The first one is being item set, a collection of one or more items. That is what exactly which we have studied in association rule mining video 2. So herein, if you say item set, this is an item set with 3 items, milk, bread and diaper. So these all items would be found here in this transaction. So the items that you're going to find there in the transaction will be there in as a set, which you're going to have here, that is being called as item set. Suppose if you are going to have one item, here in suppose assume a case you're going to have one item set with one item, then it's going to be a one item set. So the K is actually based on how many number of items being there in an item set. Now, the next term is being support count, the frequency of occurrence of an item set. So suppose if you take an example here, milk, bread and diaper. So if you look at the transaction, where you're going to see milk, bread, diaper together in some transactions. So how many different transactions having milk, bread together, milk, bread and diaper together? That is what speaking about this support count. So here if you look at here, bread, milk and diaper, bread, milk and diaper, bread, milk and diaper. So you can see here in 2 transactions, not anymore. Bread, milk and diaper together not been there in any more transaction, only in 2 transactions. That is what you're seeing over here in this. Next is being support. What is support is being fraction of transaction that contain an item set. So here, if you look at, you have an example as with support milk, bread and diaper. So milk, bread and diaper together being, as we have seen before, 2 transactions having it together, and out of how many different total transactions? That is what this 5 is speaking about. So yes is equal to total number of transactions having milk, bread, diaper together divided by total number of transactions in the database. So that is what you're going to see it over here. So here in this it is been 40%. Okay. Now another one is frequent item set. An item set whose support is greater than or equal to minimum support threshold. Why we are setting a minimum support threshold here is that those who are doing the frequent item set mining would have their own reasons. It will vary depends upon the purpose they are looking for. Then obviously this minimum support threshold should be setting by the user. So to make sure what they are finding it as, how many number of minimum times a particular item should appear in the transaction to be called it as a frequent item set. That is what exactly you're going to find out from frequent item set. For example, assume a case you're going to say you want to have an item at least 3 times in your entire transaction to be called it as a frequent item set. Then you will find out all those different which are having at least 3 times appearing in the transaction. So we can call those which are appearing at least 3 times are all the frequent item sets. Now, the next term is being confidence. Confidence is measures how often items in Y appear in transaction that contain X. So as I told you, herein you have one X wherein milk and diaper together, and you have beer here, which is as I considering Y. So I can say XY together in how many transactions? That is the support count. So you're going to find milk, diaper, beer together in how many transactions? Milk, diaper, beer together in how many transactions? Milk, diaper, beer. Milk, diaper, beer together in how many transactions appearing it. So have a look at here, milk, diaper. So here beer is not been there. So here in this, if you look at milk, diaper, beer. And here if you look at milk, diaper, beer. So there are two transactions where milk, diaper, beer appearing together. That is what you're seeing it here in these two. Then how many transactions having X alone? That would be there in the denominator. So here you're going to have milk, diaper together as in three transactions. Which are those? Milk, diaper together. This is one. Then this is milk, diaper. Then another one is milk, diaper. So these two together in three transactions, that is what this three is all about. So total we can say it is there in 67% of the whole transactions. Now, next one important term which you should know is a priori property. And the a priori algorithm works purely based on this principle. So we should understand it clearly. What is a priori principle is that if an item set is frequent, when you go into call an item set is frequent, then all of its subset must also be frequent. Otherwise, you cannot say the item set is frequent. That is what your a priori principle. From where you got a priori principle, it is actually you have got it from the support measure. A priori principle holds due to the following property of the support measure. What it says is, for all xy, x is a subset of y, then support of x greater than or equal to support of y. So here, the support of subset should always going to be greater than or equal to the support of the superset. So this is what it says. Support of an item set never exceeds the support of its subset. This is being called as anti-monotone property. Now, so mining association rules, it is actually in two steps. Why it is being in two steps, which we have already discussed in my previous video. So here, those steps is being frequent item set generation and rule generation. In the frequent item set, generate all item set whose support greater than or equal to minimum support. And in rule generation, generate high confidence rules from each frequent item set, where each rule is a binary partitioning of a frequent item set. So here, the one of the difficult tasks is always going to be frequent item set generation. Let us see why it is been later in this upcoming slides. So we can say the frequent item set generation is computationally expensive. Now, before we start the a priori algorithm, there are some prerequisites. You have to fulfill those prerequisites to start the a priori algorithm. What is those prerequisites are? Minimum support to be known, in the sense you should set the minimum support before you start the a priori algorithm. Then minimum confidence is also being set. Then obviously you should have a data set to be provided so that you go into work on that data set to bring out the association rules. Now, let us have a look into the a priori algorithm. In the a priori algorithm, as I told you at the beginning of this presentation of, the video, where there are two things which have been coming as, one is join step and another one is prune step. So in the join step, you would be seeing C. C is the candidate item set. The item set which are eligible to be considered for checking whether it is frequent item set or not. And L is that where you're going to have all the list of items which are frequent. So what is join step is CK is generated by joining LK minus with itself. In the sense, you're going to get CK from all the previous frequent item set. In the sense, assume K is your 3, K is 3 in the sense, candidate item sets for 3 item set, frequent 3 item sets will be generating from the frequent item sets of 2 item sets. So this is what it is said. Then the next one is being prune step. What is prune step? It is very, very important here in the a priori algorithm. It is purely working based on the a priori principle. Any k minus 1 item set that is not frequent cannot be a subset of a frequent k item set. What it says, let me tell once again, any k minus 1 item set that is not frequent cannot be a subset of a frequent k item set. In the sense, when you're going to make your k item set, then the k minus item set which you have used to generate this k item set should also be frequent. Otherwise, don't consider such one for frequent. Check whether it is frequent item set or not. Okay. Now, if you look at the pseudocode, as we have said, CK and LK would be initialized. Frequent item set of size K is the LK and CK is the candidate item set of size K. And you're going to have your frequent item sets, and then you would be having it in the loop of all those things where you're going to find. You will be doing this in the loop till there is no more frequent item set to generate. And this process you would continue. Then what you're going to do, you will be considering each of those transactions. Then you're going to do all those what is called joining and prune steps. Let us see all those different things once again later after seeing the example, so that it's going to be more easier for you to understand. Now, here what I am going to do is I am going to consider an example. Here in this example, as we have said earlier, as our prerequisite, what is our prerequisite? There are 3 things. One is minimum support to be known, minimum confidence to be known, data set to be provided. So herein we have a data set already available with us. So that is been ready. This is our data set or our database. It is available with 9 transactions. Then next, what is being required? The minimum support to be set. This is also been here. Okay. Then next, what is being required? You should have minimum confidence to be set. Here it is being set as 70%. So what is here? Minimum support is 2, or we can say minimum support is 2 by 9. Out of 9 transactions, at least 2 should be required. So in percentage, we can say it is 22%. So these all 3 prerequisites are being given. Yeah, now look at the steps one by one with an example, the one which we have discussed as the database for this example. Frequent item set generation is the first step, as you know. Then it will be rule generation first, and the real task is been on frequent item set generation. Let us understand it in depth. So what you're going to do first is find out all unique k item sets from the database. Then count the support of each k items. Then prune out those k items which are having support count less than the minimum support. So here let us have been taken your k as k is equal to 1. So what you're going to have? First you're going to make all the unique item sets from the database. All the unique item sets you're going to find out from the database. As we know, for calling frequent item set or frequent one item set, what is the minimum requirement is? It should fulfill the minimum criteria that at least it should appear in 2 transactions out of 9. So if you're going to go for your data set or your database, wherein you can see total 9 transactions are being here. Out of this total 9 transactions, you have different items appearing, and find out all those unique items, one item or one item set, all the unique one item set from this transaction. If you go look for that, you can see I1, I2, I3, I4 and I4. These are the unique one item sets which you can see here in this transaction. So that is what you have written over here. After scanning D, you finding out all the unique candidate items. That is why C means candidate item sets to become the frequent item set. So you're going to have that candidate item set wherein you have k is equal to 1. So your C1 it is being, and similarly the frequent item set would be L1 from this candidate item set, because Y1 is being, your k is 1. Now, what we have seen, we can see we have got I1 is 6, I2 is 7, I3 is 6, I4 is 2, and I5 is 2. Once again, let us check that how it is being got from the database. I1 is 6. So what you have to do is you just count how many times I1 appearing in the whole transaction. 1, 2, 3, 4, 5, 6. Similarly, the rest of those will also be appearing. Like, let me count one more, I2. How many times I2 appearing? 7 times that we have said. So let's see whether it is 7 times. I2, 1, 2, 3, 4, 5, 6 and 7. This is appearing in 7 times. Similarly, we have found the support count of each of that directly from the transaction database, wherein what you're going to do is you scan each of that. So that is what we have done. Now, then you have to, the next thing what you have to do is you have to check for the minimum support requirement. So compare candidate support count with minimum support count. So what is minimum support count? To be called as a frequent item set, 2. So what will be in L? L will contain all those items which are at least being 2. So if you look at this support count, you don't have any item to be removed from here or not included in here. All of those items are fulfilling the minimum requirement. 2 is the minimum requirement, so all are fulfilling. So we are going to have this all being taken into our L. So that is what we have done in the first step. That is, with one item set, we have got the candidate item sets which are being used for checking whether those are being fulfilling the minimum support criteria or not. If it is fulfilling the minimum support criteria, that will be eligible to be in L1. L1 is the frequent item set of one item set. Now, next step what we're going to do is, by using the frequent one item set, you're going to generate two item set. That means from LK minus 1. Here K is 2. Here K is 2. LK minus 1 means one item set. So L means, what is that L? L is the frequent item set list of one item set. So that you're going to get from there. By merging all the possible combinations, you're going to make it. Means when you're going to make your two item set, that you're going to make from the frequent item set of K minus 1. So you have to be careful in rest of the steps. Apply a priori property at the time of this merge. Okay, then prune out those are not frequent. Let's see one by one how it is been. So you have got your candidate here. What you have done here is you just found all your L1. L1 is being taken for, L1 is used for taking your what is called C2. C2 means K is 2 here. So C2 is generated from LK minus 1. So LK minus 1, what is that LK minus 1? LK minus 1 is going to be your your L1. So from this L1 you go into generate. So look at that I1. So when you go for merging into two item set, you're going to do it like this: I1, I2, I1, I3, I1, I4, I1, I5. Then I2, I3, I2, I4, I2, I5. Then I3, I4, I3, I5. Then I4, I5. Like that, all the different possible combinations to get two item set would be looked at. So herein one more thing is said over here. Apply a priori property at the time of merge if it is required. So herein, what is a priori property is saying? A priori property is saying, let us have a look into that a priori property once again. What a priori property says, if an item set is frequent, then the subset of those item sets should be frequent. Then only a superset can be frequent. So this is what it says. So this will help us to prune out those who are not frequent. Now, how it's going to be? Here in this, what you going to do here? Let us have a look at. You have made I1, I2. It is a two item set. When you made I1, I2 as your item set herein, so we are taking this one, I1, I2. So what are the subset of it? The subset of this is been I1 and I2. Subset of this is been I1 and I2. Where you can find this subset? You can find this subset in your previous case. What is the previous case? This is the previous case. Here in this previous case, if you look at, you can see I1 is frequent, I2 is also frequent. So obviously when you merge these two, that superset should also be frequent. This is what to be looked at. If any of this is not going to be the subset of your candidate, any of this not going to be frequent, then you will not consider the subset of those candidates you are going to take is not frequent at the time when any of this subset. Once again, if you're going to have these I1, I2 to be taken, then the subset of this particular set, that is I1 and I2 is the subset of it. So any of this one, I1 or I2 is not going to be frequent in the previous case, then you cannot have I1, I2 in your candidate set. So this is what it says. Similarly, we have looked at all of this and found it all being candidate. So we have taken all of those things. Then what's next you have to do is you have to have that to be looked at there to check each one of that in the transaction to find out what is the count of it. You have looked at the count of I1, I2. Then similarly, all of this count you have looked at so that you have seen the count of each of it. So once you have seen the count of each of it from the database, you can see this is one with support count less than the minimum required. Okay, and another one is being, this is the one with a lesser support, and this is the one with another lesser support, and this is the one with another lesser support. So what is happening in this case, we will not consider these all, or we would prune this out for reduce the search space in the next time. So what you're going to do is you're going to prune this out, and what all are qualifying the minimum support only to be taken into our L. So L only going to contain those are frequent at any case. So that is what it's happening here in this. Now let us move to the next one. Yeah, here by using the frequent two item sets, generate three item sets by merging all the possible combinations, apply a priori property at the time of merge, prune out those are not frequent later. So here what will be your K? Your K will be 3. Your K going to be 3. Now your minimum support remain as the same 2. Now what is going to do here, this step is very, very important. You have to be carefully understand what we are going to discuss here. In this step, if we are going to have the candidate set to be generated, so here the candidate set you are going to get as generated as only 2. I mean with 3 item sets. Why and what is the reasons to be so? So to understand that reason, let me have it's looked at in the next slide. So herein, what we have done over, this is that C2 and this is your L2. You have to generate your C3 from L2. What a priori property says here, any k-1 item set that is not frequent cannot be a subset of a frequent k item set. So here what is k item set? 3 item set. Okay. Now the k-1 is your frequent item set, L2. Previous frequent item set, that is L2. So here in L2, these are the only frequent item sets. So when you generate your 3 item set, then all of its subsets should also be frequent. What is the immediate subset? So when you look at that immediate subset, all of this immediate subset, what is going to be? That is your, for example, let us take I1, I2, I3. When you take I1, I2, I3, the immediate subset with 2 item set going to be I1, I2, I1, I3, I2, I3. So here if you look at I1, I2, yes, in the here I1, I2 in the previous frequent item set list is 4, it is frequent. Then another one case is I1, I3. So if you look at I1, I3 is also frequent here in this. Then another one case is I2, I3, I2, I3. Yes, I2, I3 is also frequent. So all of those possible item sets of the previous 2 item set is also frequent. So we can say it can be considered as a candidate item set. So the next one we can look at the possible merging. What it has been? I1, I2, I5. I1, I2, I5. When you're going to have I1, I2, I5, yes, what are the possible subset of this of 2 item set? I1, I2, check. I1, I2 is already 4, it is frequent. Then next is I2, I5. Yes, if you look at I2, I5 is also frequent. Minimum requirement is 2. So this is also frequent. We have seen it in the previous L2. Then what is next is been I1, I5. Have a look at I1, I5. That is also frequent. So we can have that is also been considered. Now look at another possible combination from this. That is been I1, I3, I5. When you go for I1, I3, I5, what is going to happen would be I1, I3, I5. From this, if you can find of all those, what is going to happen there would be I1, I3, I5 is actually the subsets. Have a look at the subset. I1, I3 is one of the subsets. Yes, I1, I3 is frequent. Another subset is been I1, I5. Yes, I1, I5 is also frequent. Next, you look at I3, I5. That is another subset. I3, I5 was not frequent, so it was removed. And in the frequent L2, frequent item set L2, that is not been available. If that is not available in that, then what is going to happen would be that would not be considered. That would not be considered for your frequent item set generation. So there is no need to be considered that as a candidate item. So that is what actually happening here in that. So similarly, you have to look at all of those. You can find other than I1, I2, I1, I2, I3 and I1, I2, I5, there is no one. So we are going to have finding out the subset is frequent or not. If the subset of those merging is being frequent, then only you are going to consider that. So that is the reason we have got only I1, I2, I3 and I1, I2, I5 as the candidate here. For that, what we have done, we have applied the a priori property there. Once you apply the a priori property there, then what is the possibility is that there is no need to unnecessarily do a scanning over there in the database with that item set which are sure about not going to be frequent. So this is what we have done over there. This will reduce the search. Now, what we're going to do then with that, which are candidates, you're going to find out the frequent item set. For this, you have to have it to be searched in your transaction database. So where are you going to search and find out how many number it has been. If you search I1, I2, I3 and I1, I2, I5, you can see that in your previous one, I1, I2, what was all? I1, I2, I3 and I1, I2, I5. I1, I2, I3, how many times? You can see that I1, I2, I3, I1, I2, I3, 2 times. Then I1, I2, I5, I1, I2, I5, then I1, I2, I5. That is also 2 times. So these all are fulfilling the minimum requirement. That is what you are seeing it over here in. So all those which are being fulfilling the minimum requirement is being shown over here, and that all those two fulfilling the minimum requirement, so that it's been taken into your L3. L3 means all the frequent item set with 3 items. So that is also been here. So here in the next case, where we're going to go for 4 item sets, by using the frequent 3 item set, generate 4 item sets by merging all the possible combinations. Apply a priori property at the time of merge, the same way like what we did in the last step. As there is no frequent item set, then algorithm stops. So what we're going to do here is, we're going to have the L3 to be. What is L3? L3 is going to have all the frequent item sets which are of 3 items. Then that would be looked at while you go for merging, whether the subset going to be frequent or not. Otherwise it will prune off. Now what is being done when you go for merging it, I1, I2, I3 and I5 is the possible merge here. When you go for I1, I2, I3, I5 merge and to generate the candidate, you're going to have a check to be done whether it is subsets also been frequent or not. So herein, when you look at what all are the subset, the immediate previous subsets, what are going to be? You can see I1, I2, I3. Yes, I1, I2, I3 is frequent. I1, I2, I5. Yes, that also been frequent. But when you look at I2, I3, I5, I2, I3, I5 is not in this list. The meaning is that it is not frequent. So at least one of the subset is not going to be frequent. If it's not going to be frequent, then obviously this 4 item set is also not going to be frequent. So we can say we cannot have that to be considered for candidate. So this is not going to be frequent, and we are going to stop our algorithm here with L3. Now, once it is been stopped here with L3, what you're going to do next is you're going to you take all those frequent right from L1, L2 and L3 would be taken together for association rule generation. That is the next step. I have told you at the beginning, in the a priori, there are two different, in the frequent item set mining, there are, association rule mining, there are 2 steps involved. One is frequent item set generation, then generate all the strong rules or generate the rules. So herein, what you're going to do is we have already completed the frequent item set generation as much as possible with the k item sets. Then the next thing what we're going to do is we're going to generate the strong rules. So when you go for generating the strong rules, it would be generated from the available frequent item sets. Herein L1, L2, L3 are the available frequent item sets of different size. So we're going to have your L at the end for generating the association rule is being the merging of L1, L2 and L3. That is what we have done over here. We're going to have this all being taken together. That is what you're going to see. These all are being the possible combinations you can try for the strong rule generation. How will it going to be strong rule? These all to be tested with different possible association rule combinations to find its confidence. If the confidence is being the minimum required, what we have set as the minimum required confidence, we have already set our minimum required confidence at the very beginning as 70%. So once we have set it as 70%, whoever get through the minimum required confidence, then those all are going to be the strong rules. So herein what we're going to do, find the confidence for the confidence of that is minimum confidence. For each association, we have to check it with minimum confidence. So find out the confidence first. Confidence for each association rule for knowing whether it qualifies the minimum confidence or not. If it qualifies the minimum confidence, then it is selected as strong rule. Otherwise, will be rejected. Let us take from here one of the example that is been I1, I2, I5. So in that I1, I2, I5, it's all non-empty subset. The possible non-empty subsets are I1, I2, I1, I5, I2, I5, I1, I2, I5. So we going to have first to be checked with I1, I2 implies I5. I1, I2 implies I5. So here, what is the confidence you going to, what is confidence? Confidence is that when you take I1, I2, I5, I1, I2, I5 together, support of I1, I2, I5 together divided by the support of I1, I2 alone. So that is the confidence. If you get that, what it's going to be, here you can see it is 50% is the confidence, then that rule cannot be considered because it never going to qualify the minimum confidence. What is that minimum confidence? As we have said, the minimum confidence we have already said earlier at the starting it as 70%. So it is not qualifying that minimum. So this is been rejected. So then next what we going to take I1, I5 implies I2. So look at the confidence here. It's getting the confidence as 100%. So we could say it is selected. It is selected. Then similarly I2, I5, I1. It's all from this, all the different combinations. You're going to find out and it is also 100%. So that is also been selected. Then you would go for I1 implies I2, I5. So find out the confidence. If that confidence here in this is less, so it is rejected. Then next is I2, I1, I5. I2, I1, I5 from this. So you look at that confidence, it is again less, so it is being rejected. And next one is I5 implies I1, I2. Check what is the confidence. It is being 100% above or equal to 70%, so it is being accepted. Similarly, you would find out for all of this in a different combinations with its subsets. So you would be going to have finally all the strong rules in your hand. Hope you understood what is a priori algorithm. And thank you. Thank you so much. We will meet again with another video. Thank you so much.